Thank you everyone for joining us for this webinar on lighting with LED for television presented by Robert Grabler. My name is Laura Lawrence and I'm the Global Marketing Director at Harman. So just a few things before we get started. Everyone on the call is muted to keep down noise levels during the webinar. However, there is a chat function where you can submit questions to the presenter and they will try to answer as many questions as possible at the end. This webinar is also being recorded and the link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control, and we'd like to encourage you to take a look at the different webinars in our Learning Sessions workshop series that can be found on pro.harman.com, as well as visiting Harman Professional University to see our many on-demand and certification courses that are available to you for free. And now I'd like to introduce you to Robert Grabler, the presenter for today's webinar. After starting his lighting career in 2000, Robert became a senior lighting designer at Gearhouse South Africa, one of South Africa's leading AV suppliers in 2013. With a broad range of skills and an eye for details, Robert believes in sticking to simple standards and principles. Now I'll pass the mic over to you.
Thank you very much and welcome everybody. As mentioned, in the last 7 years, the evolution of LED light sources has seriously stepped up into overdrive. This has a huge advantage to lighting in remote areas with power restrictions, depending, of course, on your weapon of choice. So, before we kick off on this, now is a good time to mention that everything in this presentation is based on my own practical experience and what I've found to work for me. I would like to acknowledge that there are a few ways to go to work and to achieve a better or similar result that might not be mentioned. Please feel free to share those experiences with us. When we get to the question Q&A section, let's hear them, or you can share them via email or social media, any way you like. This is a topic that I'm sure can evolve into a reputable series. Please note, I will only be looking at live entertainment lighting for television and not any specific studio or film lighting. I'm sure you know by now I like sticking to simple standards and principles. Let us start at the beginning. When designing or lighting for television that involves song, dance, and drama, trust me, there's always a lot of drama involved, even on a game show. There's one thing they all have in common. It's always a kind of magic, and we need to help create that magic. Sometimes it's easy, and sometimes you wonder, what on earth am I doing? There's a very good reason why lighting is first on the list. Without good lighting, the best camera in the world can't capture a perfect picture. Lighting tells the audience where to look. I believe every performer and actor ultimately responds to light. Do the basics well. If you don't know the rules, you don't know when to break them. Make each scene or performance pop. Take the audience on a visual journey that they will never forget. Famous quote from Nadia White, one of the directors I like working with. My challenge to the lighting designer is to give me depth with separation so that the performance can pop on screen. This contrast has to be balanced, of course, with the base light level required for television. I'm not a fan of traditional flat light TV. I like to create images that look more like film than video. This story carries on here and how Andrew likes color, one of the better creative directors I've worked with in South Africa. We first worked together on the X Factor South Africa. When filming, shooting an event, our primary expectations is to have an evenly lit venue. Cameras are very much more sensitive to light intensity than our eyes. So dark spots or bright spots are emphasized significantly. Likewise, they're also far less tolerant to color temperature. It happens regularly to the key light and general stage wash at different color temperatures, and the presenter walks from warm to cold. Brendan Marseille, one of the best broadcast engineers I know. Right, so based on these three different categories of people working in television, let's take a look at a few things. LED lighting has changed the landscape in recent years. The flexibility has added to create the perfect memorable moment where the audience feels exactly the emotions you want them to feel, and has been incredible, especially on shiny live music reality floor stages. What is needed to make television? Light, camera, action. Lighting. I'm sure this is the easy part. When you know what the concept is and what is required, you can put your skills to good work, and you can create it all with a dash of magic. Camera. This is an important piece of equipment. It helps captures moments of magic and is used to tell the story to all the viewers at home. Understanding how it works will help you in the long run. Let's face it, you have different types of cameras. Some of them are great, while some of them are, well, let's just leave it there. Nevertheless, most of them work the same way. And of course, we all want action. You need to understand what you are doing and why. What are you lighting and what the concept requires to make it look like something. So, what do we need to know? Before we dive in, let's take a look at a few important points. I'm sure most of you know already by now, but stay with me. I'm sure this will help someone, or it might just explain something you might have known a little bit better. What is a white balance? A white balance is the process of removing unrealistic color casts. So the object which appears white in person is rendered white on camera. Proper camera white balances has to take into account the color temperature of a light source, which refers to the relative warmth or coolness of white light. Our eyes are very good at judging what is white under different light sources, but cameras often have great difficulty with this. This can create unsightly blue, orange, or even green color casts. Understanding white balance can help you avoid these color casts. What is color temperature? And what color temperature are you lighting in? The color temperature of light source is the temperature of an ideal that radiates light of a color comparable to that of a light source. Color temperature is a characteristic of visible light that is important applications. In practice, color temperature is meaningful only for the light sources that do in fact correspond somewhat closely to the radiation of some black bodies, like for example, light in a range going from red to orange to yellow to white to blue, blue-white. Color temperature is conventionally expressed in kelvins, and that's the unit we measure absolute temperature. Color temperature over 5,000 kelvins are called cool colors. Those are more your bluish, where your lower color temperatures, 2,700 to 3,000, are called your warm colors, often more yellowish. What is CRI? I'm sure you guys in the last while, especially at expos, have heard the word CRI a lot, especially with new LED sources going, it's got a CRI value of X and. By definition, color rendering index is a quantitative measure of the ability of a light source to reveal the colors of various objects faithfully in comparison with an ideal or natural light source. Brad did a blog about 3 years ago called Understanding Color Rendering Index. I would like to highlight a few facts out of this blog. CRI, or Color Rendering Index, is currently the most commonly provided metric for color rendering. Basically, it consists of 8 colors that are given a 0 to 100 score and simply averaged together. The 8 colors primarily consist of skin or natural tones, but not any saturated hues. Because these 8 values are simply averaged together, it is possible to get skewed results The full CRI spectrum consists of 14 colors, but typically only the first 8 are used for calculations. Typically, LEDs have a CRI of 80 or more, so it is stated. If you go and Google CRI and you scroll down on Wikipedia, you will find a part labeled Film and Video High CRI LED Lighting. It states the following. Problems have been encountered attempting to use LED lighting on film and video sets. The color spectrum of LED lighting primary colors does not match the expected color wavelengths band passes of film emulsions with digital sensors. As a result, color rendition can be completely unpredictable in optical prints. Transfer to digital media from film and video camera recordings. To that end, various other metrics such as TLCI, which stands for Television Lighting Consistency Index, have been developed to replace the human observer with a camera observer. Similar to CRI, the metric measures quality of light sources that would appear on camera on a scale of 0 to 100. In Brad's blog, he also talks about TLCI. With so many different color rendering metrics to choose from, it can be confusing to determine how well a specific light will render colors. It is important when comparing fixtures to understand how scores are calculated and what they are based upon. CRI is the worst choice, while CQS and TM30 are much better references. TLCI should always be used for television. I really like this blog. Please do yourself a favor and go check it out. It'll take you about 5 minutes and it's a great read. Hey Brad, would you like to add anything before we move on?
No, you covered it very well, Robert. Just the one thing that I'll reiterate is TLCI is the color rendering metric that is designed for television. And that's the one that television designers should reference when looking at white light, is TLCI.
Okay, great stuff. Just keep your pen ready there in case we get a question with regards to CQS or TM30 later. Let's move on. This is very important to extent to understand how cameras interpret light. I am not going to touch in depth on it, but I think I'm going to give you a fair idea. And if you want to know more, I'm sure you can pop me a mail, and if I don't know the answer, I definitely know someone that can give you the answer. Right, let's do this. Now that we've briefly touched on white balance, color temperature, CRI, and TLCI, let's get a basic understanding how camera interprets light. As a camera typically produces a two-dimensional image, it is important to run backlight on your subject. This creates a highlight around the subject and gives good separation between the back and the foreground. Our stereoscopic vision can determine depth, but unless there's a visual separation in a 2D image, the scene can look flat. And on screen, your presenter or subject can look like a cardboard cutout if it's not lit from more than just one from the front. Most professional cameras are 3CCD and run a prism to split the light to the sensors. The RGB value that is received at a single point determines the color. A pure white image is an equal voltage from each sensor. The camera vision controller can gain each of the sensors' output to create white or to match the white. Once this white balance procedure has been followed, the same white object can appear on screen as bluish, greenish, or reddish if the light color temperature varies whilst the camera setting remains constant. Whilst our eyes would fake the white in the venue, when the camera is the only frame of reference on a monitor, that white does not drift far more noticeably. As with any wave energy, it is inversely proportionate to wavelength. As such, the longer wavelength carries less energy than the shorter wave of the same magnitude. This is why cameras render reds and yellows better than blues and purples, because a tiny change in magnitude of the wave results in significantly more energy of the wave. This energy is converted into voltage, and the dynamics are less easy to control in the blue and the purple spectrum. This is why we so often see cameras freak out when we use Congo blue, or we go to full blue on a LED chip with no other color added to it. The power density curve also shows us why it feels like we need more light at lower color temperatures, and also why tungsten bulbs warm up when dimmed. Image noise on cameras. The higher the frequency, the easier it is to disturb when converting from light to volts within the chip of the camera. As a result of this, the blues will become noisy first, once again giving a blue render on camera less definition. I don't know if you guys remember, there was a blue-only mode on monitors used to look for artifacts and signal noise. Now it must be said that this was a trait of the older cameras and analog distribution systems. The newer all-digital cameras do not suffer from this, but with a blue LED source, we can still push that boundary if we really wanted to. LED emitters run at a constant voltage. They're either on or they are off. To get an LED to dim, two methods are used: pulse width modulation or frequency modulation. PWM determines the amount of times the LED is on within the given time frame, where FWM changes the time frame of the pulse rather. This fluctuation in time frame has a negative effect on cameras. As the camera source light over a defined period of time, if the light is off during that period of time, the camera seizes the darkness. If the light is on, it seizes brightness. Typically, cameras run at 50 to 60 Hertz, and LED lighting flashes are significantly higher than this. If, however, the frequency is not a multiple of the camera base frequency, we will see flickering. As you can imagine, with FWM LED sources, the frequency changes as light is dim. So, whilst at 100%, it may look perfect on camera, as the source is permanently on. When the light is running at 50%, it could be running at a frequency which does not match the camera shutter. Very few modern LED fixtures run FWM, but some of the cheap multicolored ones do. And these are best avoided if you have a camera anywhere nearby. Rather use them outside in the garden. PWM doesn't entirely eliminate the problem, however. Unless the light runs a very strict PWM clocking signal, its frequency can fluctuate marginally and create issues. If a RGB cluster is running at a different percentage, you can see that the on pulse will always be synchronized, but the off pulse will be differently per color, creating a frequency harmonic, which the camera could also pick up on. We notice this with color shifts at different shutter speeds on the camera. Ultra-high definition cameras require aperture settings that will let in the ideal amount of light. As broadcast resolutions increase, so does the required aperture settings. When the ideal amount of light is achieved, the lighting reaches the camera's digital sensors, optimizing the field depth and minimizing the adjustment required by the camera operators. While light quantity is very important for broadcast, light quality is perhaps more so. One critical aspect of light is how well it enables the accurate depiction of colors on the broadcast. The biggest change we've seen in the industry has impacted on lighting in recent years was the move from film to digital HD. This saw the fastest movie lenses linked to highly sensitive sensors, so the overall light levels required to get a good picture could be lower. Also, the emphasis for lighting directors moved more towards painting with smaller strokes rather than large swaths, a process that can be easily achieved with LED fixtures. Every brand of camera will have a slightly different spectral response sensitivity. Now that we have a better understanding on all of this, let's move on using the lights we have in the shop or whatever you have available to make some action. Using some of the properties of light, we can achieve the correct desired effect. Properties of light, I'm sure somewhere long ago you remember this from a training course. So, I want to cover 3 different topics. Intensity. Controlling the intensity is one of the first things anybody will do. This will help manage the light levels, and life doesn't always start at full. Dimmer curves on various LED sources are different. Only recently have the manufacturers been focusing on smoother dimming curves. Working with LED sources, I found that you can start working in increments of 5% before jumping to smaller increments. Color. Start building those color correction palettes. Now, I've got to warn you, might keep you busy for a few days. Go to your preferred color temperature. Make sure the color temperature is maintained as you adjust the intensity. White balance your cameras accordingly. Depending on the control equipment on the project, you might even want to color balance the LED screen video. Depending what fixtures you use, check that your color temperature stays true as you adjust the intensity. I will touch a bit more on this later. Some colors will look slightly different on screen than in real life. Don't freak out. Remember, you are lighting and looking at a reference monitor. As long as it looks good, you don't need to worry about it. It's slightly off in real life. If it's off by quite a bit, you might want to revisit your preferred color temperature you're white balancing to. Shape. You can, to a certain extent, manipulate the beam shape to assist with intensity and color mixing. If the intensity difference of 1% is too extreme in a low light environment, you can simply manipulate the zoom or bodge the focus slightly instead of readjusting the color mixing to get the desired color temperature. But I have found that this is on minute changes and doesn't always work. It can be a cheat. Try it, you never know. Currently, we have 2 types of LED light sources in the live entertainment environment. We have our multi-chip fixtures. They have clusters of RGBW, some of them are RGBW amber. And as a light source, for example, let's look at the Mac Quantum Wash, the Auras, and so the Rush bars, and so on. Think of it as an additive color mixing system. And then we get our multi-cluster LED white light engines. This will only have a white light source and will work with standard color wheel or CMY, like the Quantum Profile and some of the newer fixtures. You can think of this as a subtractive color mixing system. Okay, so I'm sure by now you know the difference between the two. I took some time last week to run some tests, and boy, were they interesting. I feel it's very resourceful to know. So in our two categories, I did the following. Took a MAC quantum wash, a generic RGBW profile unit, and a good old generic RGB LED par to see how clean white I could get out of it. I also took in the plain LED engine 3 different units. I opted to go with a quantum profile, a generic profile with built-in CRI color correction, and a generic profile without CRI color correction. I used the Sekonic SpectraMaster C800U and a Vectorscope with a Sony XD HD cam to do this test, a Vectorscope. What I was looking for was the following. I did default color temperature with CRI and TLCI. Wanted to see how accurate the pre-mixed color temperatures are to what the manufacturer states they are, and how to get to it. I'll explain a bit more about that one later. How close I can get to 5,000 kelvins by mixing all the colors and readings to CRI, and mixing all the colors and reading the CRI and TLCI readings on it. That just also how fast the readings go false when changing the intensity, and what I had to do to maintain a true reading. Let's have a look. So, with our additive color mixing systems, as you can see here, we had the quantum wash, the RGB spot, and the generic one. Each one had a default color temperature of 6,500 kelvins or higher. You'll notice on the RGB generic fixture, it read over on the meter. So I'm not too sure to understand why or how, but we'll move along swiftly. As noted, according to the meter, CRI level was fairly high on the quantum wash, where on the RGBW spot was fairly low. And after taking the individual chips, the closest I could get to 5,000 kelvins was slightly over. Now, this is probably a good place to mention that a camera won't pick up a deviation of up to about 100 kelvins, depending at what intensity you're setting and how accurately you've color mixed it. You will notice that the CRI and the TLCI, after attempting to get to 5,000 kelvins with the color meter, actually went significantly up. The interesting thing, and this is what I hope you notice over here, is that when you dimmed that color, the color temperature would go down gradually. But in certain cases, and over here, when you would get down to about 30–20%, it would go up again significantly and become colder. I took the same fixtures, put it on a Vectorscope, and just for interest sake, put the RGB values down here. So if you ever want to cheat with these fixtures, to do that, you can do it. And you'll also notice that there is slightly a difference in the CRI and the TLCI. But I can say that this was the most accurate we could get it to 5,000 kelvins. Okay. Moving on to the single light white source. This was also very, very interesting. As you can see, same story. Interesting enough, the generic profile with a CRI correction, light engine, and the other unit without CRI corrections, light engine, I found out was manufactured in the same factory. So the only reason that the color temperature, default color temperature, would be slightly different would be thanks to the different lens assembly or the reflector on it. All of these units have a fairly high CRI, TLCI, according to the meter, and I could get them a lot closer to 5,000 kelvins. This is a good place to probably mention that out of these three pictures, the Mac Quantum Spot does not have a CTC flag in it. It's got a set color flag in it. So this color temperature was purely mixed with CMY. We can see that the CRI and the TLCI went down slightly, some of the units, but we can also see a lot less of a change in color temperature as we dimmed the units. Once again, most of these units' color temperatures ended up spiking a little bit up to the colder side once we hit 20%. If we look to what they did on camera on the vectorscope, it's fairly relatively flat, and hence the reason I can say I'm convinced these two units over here were manufactured in the same factory, because even with or without the CRI correction, I could not get the green to match the red and the blue. There were cases where we managed to get it to invert, so the green was a little bit higher than the red or the blue, but there was no way of getting it perfectly flat like we managed to get you in Quantum Spot. This is a good place where I actually want to just quickly jump back to the Quantum Wash. I know it's been around for a while, and I know a lot of the newer multi-chip LED fixtures Martin's brought out has been based on the same color technology on it. You can, on that unit, at any given stage, if you dim the intensity, manage to get the same color temperature by using the pre-mixed color temperature channel on the unit. All you do is, as you dim it, you just dial a little bit more in to cool it up again, and you can pretty much have the same color temperature from 5%, 1% to 100%. It's really, really amazing piece of technology. I mentioned earlier that I would like to know how accurately, sorry, just give me a second here. Okay. I mentioned earlier that I would like to know how accurate the pre-mixed color temperature to what the manufacturer states and how easy it is to get to them. Here are my findings and my thoughts of this. Most of them were correct, but not to the Kelvin. At 100% intensity, they were maybe out with 30 to 70 kelvins on average. This was not noticeable on camera. Taking intensity down, the color temperature would lower slightly, but around 40% it will spike up higher, as mentioned. Same as most of the tests done. I think it's safe to make a statement, specifically on single color white light source, that it has the opposite result of a tungsten bulb. The lower the intensity, the higher the color temperature. As for how easy to get to the pre-mixed color corrections, on multicolored light sources, let's just say Martin got it right on day one. Most other manufacturers opted to do the color wheel option. Go check out this video. It's about Martin's advanced color mixing system. This is one of the biggest reasons 6 years ago I started exploring this. Using fixtures for more than one purpose, I want to be able to fade out from a beautiful color correction fixture into a soft blue or whatever color I choose for that magic moment. I don't want it to snap through colors or use a second fixture to do a light crossfade. So, my final thoughts. Most fixtures can work even though some units will not look great on the eye. I used 5,000 kelvins on this case study as it's pretty much on the fence between warm white and cold white. Always insist on a monitor with a waveform or vectorscope whenever you work on television. Very important. Make friends with the vision controller. You guys need to work together. It'll always be great. Don't be scared to build your own color temperature presets. If the pictures look different on screen versus real life, don't sweat it. It's for television after all, unless, as I mentioned, there's a huge difference. Then the odds are that your color temperature of choice is too warm or too cold. LED lighting is very misunderstood as a result, and TV traditionalists will always stick to tungsten and carbon arc lighting. It is not all bad, however. LED has improved significantly, and lighting designers and broadcasters can be friends under the LED hood. Thank you very much for your time.
Thanks, Robert. We have some questions if you're ready for them.
Yeah.
All right, the first one, on a typical television show, how much do you interact with the video engineer to ensure the imagery looks correct?
Okay, so in South Africa, we refer to them as the vision controllers. That is the first person you need to get to know. I always make a plan to find out who he is, and if I have not worked with him before, I'll always show up with a cup of coffee and we have a good chit-chat. We get a game plan. Usually how I like working, and they're more than happy to comply, is we get a white balance. We set the irises to the f-stop I would like to work in, and then they just sit back and let me do my work. They have my full permission at any given stage while I'm busy programming or getting the show together to chip in, get on the clear comms and go, hey man, these are my thoughts. The main reason I do this is when the show goes, especially live shows, it gets very busy. There's something you might have missed. The odds of the vision controller working his butt off is way lower if you get the fundamentals right in that concept. And I also found it to the point that if he doesn't work too hard during the live show and you're in a bit of trouble and he needs to bail you out, they usually comply a lot quicker and easier. You don't have to beg them.
Okay, next question is asking, what color temp do you typically try to white balance to on a gig?
It depends on the nature of the show. Due to the huge variation in demography in South Africa, I tend going a little bit warmer than daylight because sometimes daylight looks a bit strange on dark skin tones depending on the nature of the show. So I would sit anywhere between 5'3" and 5'6". I hope that answered your question.
And then a follow-up question, who decides the color temperatures that the cameras will be balanced to?
Ultimately, I would think it's up to you as the lighting designer or the person that's going to run it. Often you have a mixture of discharge lamps, some follow spots, some LED in there, and you need to find the common ground on everything.
Okay, next question. Next question is, what mistakes do you seem to notice the most with people who are new to lighting and television, and what are some bad habits you see with people who are more experienced?
I think one of the most common mistakes probably made is, I've seen this light, I think it's bright, I think it'll do the job, or they just blast the front white light for the cameras to read, and then they try and compensate with too much smoke to get a pretty picture. The best advice in that context, and sorry, I might be drifting off topic here a little bit, is, as I've mentioned, cameras can handle a lot lower light levels. Decide on an f-stop for the camera, work according to that, and the lower the light levels are, the less smoke you have to use, the prettier your pictures will be. Because the worst thing that will happen is the person doing vision control will just crush the blacks and all your pretty pictures will go down the drain. I think one of the most common mistakes experienced lighting designers sometimes make is that they can either get too relaxed and rely on the vision controller to do most of the work, where it's always not a good thing. It's a team effort. So yeah, I hope that answered your question.
Okay, next question is, do you always get a perfectly tuned reference monitor?
I don't, and then I usually get a little bit grumpy. In South Africa, apart from working with Brendan from EFX, I probably only work with 2 of the major broadcasters, and they, knowing the people that run the outside broadcasting units, they know by now, when you bring this van, that's a reference monitor I want, because I know how they work and I understand how to read them. Because each reference monitor or broadcasting monitor, to a certain extent, works a little bit different, or you need to understand, especially if you, with some of the newer LCD or LED screens you get. If I notice that I'm not going to come right, I usually make a plan to bring my own one along.
Okay, next question is asking, what are your typical fade out, fade up times?
Television, I usually default to about 2 seconds, sometimes 1 to 1.5. The only time it'll be slower is depending on the performance piece and what is required of it. I think the longest I've ever taken to fade up on a live television broadcast was about 12.5 seconds, maybe, or a little bit more. But like I said, we are creating magic. We're having an amazing moment, and you've got to get the people excited at home. So use your own creativity. If you're not sure about it, speak to your director. The director has got the hardest job of all of us. They need to try and capture for people sitting at home what the live audience member is experiencing without losing any of the hype. So push the boundaries, break the rules, and if you're not sure, have a conversation with them. I'm sure you can find some common ground.
Okay, next question is asking, do you almost always use LED fixtures?
Yes, I've become a great fan of them. I remember we received our first big stock of LED fixtures back in 2013 when was before the single light source engines. And they literally arrived. They made a U-turn in the loading bay straight into the truck, and I did the last season in South Africa of So You Think You Can Dance, not having an idea how this will work, how it will react. And we ended up running that show on about an average f-stop of between 9 and 12. And only after, I think, the 4th episode, I went, okay, hang on, let's turn this down, let's make the pictures prettier. Ever since, I've used it as much as where I can, because I find that it's a more reliable light source. The thermals won't kick off, especially if it's a very critical light in the rig. And it just gives me a smoother dimming and color mixing system. Once you get a better understanding how every unit works on its own characteristic.
Okay, the next question is asking, is it difficult to light when working with an LED screen on stage?
It can be. One thing we have to make peace with as lighting people is there will always be video to tell the story. The great thing about it is it also has reduced some of our programming time because you just need to support the video screen. It's important to have a great relationship with whoever does content on LED screens to try and get a happy color balance and output level on it. And then, you know, if it's a creative musical piece or something like that, nothing stopping you going, hey man, I feel this is a bit more of a lighting moment. Can we take the video screen down a notch, or, you know, simplify to something basic like a still? Let me have my moment, and then we go into a powerful video moment where I support you again with a bigger lighting look. It's all about relationships via different departments, creating something amazing together. So I haven't really had that problem, because everybody that I work with that run LED screens have always been keen to work together and compliant, and we always help each other out to make it look great.
Okay, super. It looks like that was the last question that came in. Robert's contact information is up on the screen right now, so if you do have any additional questions, it sounds like you're open to having people reach out to you directly. Robert, thank you again for presenting. It's always a pleasure to have you on as our presenter, so we appreciate that you've now been with us a couple of times.
My pleasure.
So
cool.
That's it from us. Thanks, Brad and Heather, for being on as supports, and thank you everyone for attending. If you want to see our upcoming sessions, you can see the full calendar at pro.harman.com, and have a great rest of your day.
Thanks, everybody. Take it easy.
Thank you, Robert. Great job. I enjoyed it.
Bye.